subtract with unlike and like denominators. But for mixed numbers, we are going to keep it simple. And in fourth grade, we just learn how to subtract like denominator mixed numbers. So mixed numbers with like, I'm just going to put subtract here too. Subtract mixed numbers with like denominators. Okay, so let's do a practice problem. 5/6 minus 4/12. Okay, same as addition, you need to have the same denominator before you subtract. That's because if you have different sized pieces, it's no longer fair. Okay, so if you have 6 here and 12 here, it's 8, 9, 10, 11. This is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I have 12 pieces, and we have to make them the same because we can't subtract 4 pieces from 5 because these are much bigger than these. It's not fair. So what we're going to do is we're going to decide which one we're going to change. So we can either make these bigger, make these pieces bigger, or we can make these pieces smaller. So for 12, can I turn it into 6? Sure, yeah, I could divide by 2. Can I do the same thing to the numerator? Yeah, it's divisible by 2. So I'm actually going to change. This one will stay the same. I am going to change 4/12. So I need to multiply by a number. Oops, it's not going to be 12. I'm going to divide, not multiply, because I'm making the pieces bigger. I know it sounds like the opposite, but it's going to divide by 2. Divide by 2. And so that would be 6ths. And 4 divided by 2 is 2. Okay, so now that we have the same size pieces, I can actually subtract. 5 minus 2 is going to be 3/6. And then I simplify, so I find the greatest common factor for 3, the greatest common factor, or for the greatest common factor for 3 and 6. So the factors of 3 are 1 and 3, and that's it. 2 doesn't work, 3 works, and we're at our reciprocal, right? That's the same thing as that, but flipped. So now we're done here. 1 times 6, 2 times 3. Does 4 work? No. Does 5 work? No. Does 6 work? Yes, it does. Oh, sorry. Oops, I forgot 3. 3 does work as well. Oopsie. 3 times 2 works, and that's our reciprocal. Check. Now we look at both of them and we try to find the biggest number they have in common. The biggest number here is 3. Does it have 3 here? Yep. So I know that I'm going to divide by 3. I'm dividing by the greatest common factor. 3 divided by 3 is 1. 6 divided by 3 is 2. So it's half. My answer is half. Okay? All right, so that's how you do unlike denominators. For a number that's a little bit more challenging, so for example, if I have 5/7 minus 1/3. Okay, this one's a little bit more challenging because I know I can't multiply 3 by anything to get to 7, and I can't divide 7 by anything to get to 3. So now I have to think about my least common multiple. because we're going to have to change both of these. If we're changing both, we're thinking of the least common multiple. So we're finding the least common multiple of 3 and the least common multiple of 7. So we're skip counting by those numbers. 3, 6, 9, 12, 15. What else comes next? 18, 21. And let's just stop here. I'm going to see if I see anything in common with 7. 7, 14. Still no. 21. Does 3 have 21? Yes, it does. So it's the smallest number they have in common, the least common multiple. So I know that I'm going to be changing this one to 20-onths, and I'm going to be changing this fraction to 20-onths. I multiply 7 by 3 to get it to 21, which means I'm going to do the same thing to the 5. I'm going to multiply it by 3 as well. I multiply 3 by 7 to get it to 21, which means I'm going to do the same thing to the numerator, multiplying it by 7 as well. 5 times 3, that's 15. 1 times 7 is 7. And now I can subtract. My denominator stays the same. 15 minus 7 is 8. Yes, 8. And now I take a look at it and I see, okay, can I simplify this at all? If I don't see it automatically, I should probably draw t-charts to find my greatest common factor. 8, oopsie. I'm not doing it in the right order. You want to go in number order. So 1 and 8 works. Does 2 work? Yep. 8's an even number, so 2 is going to work. 2 times 4. Does 3 work? No. Does 4 work? Yes. And that's our reciprocal, so we know we can stop. 21. We have 1 and 21. Does 2 work? No. It's odd. Does 3 work? Yep. 3 and 7. Does 4 work? No. Does 5 work? No. Does 6 work? No. 7, yes, 7 works. So we stop there. Now I take a look at them. What's the biggest number they have in common? The biggest number they have in common is actually 1. That's the biggest one they have in common. If you divide something by 1, there is no change. So the simplest form for 8/21 is 8/21. So that's the answer for that one. Okay, let's do a mixed number problem. These are a little bit more challenging. We're going to start off with an easier one where you don't have to regroup. But I have 2 and 3/4 minus 2 and 1/4. Okay, same thing as with the addition. You subtract the whole numbers first. So 2 minus 2 is 0, right? I'm going to add that in there just so that we know. But later on, you'll erase it. And then for the fractions, we subtract those as well. 3 minus, oh, by the way, fourths, it's going to stay the same. 3 minus 1 is 2. Okay, so then when I rewrite it, I have 0 wholes. 2/4. Can I simplify this? Yes, I can. The greatest common factor is 2. That's half. So 2 and 3/4 minus 2 and 1/4 is half. Okay, so this one was pretty fast. But what happens if I have 2 and 1/4 minus 1 and 3/4? This one's different because when you take a look at your numerators, the one that you're subtracting from is actually smaller than the number you're trying to subtract. So we are going to have to do some regrouping. That means that we are going to shift around our numbers so that we end up having a bigger numerator. So we're going to create something that isn't a simplified mixed number. So 2, for 2, we're going to pull out a whole, and then we're going to leave a whole. but we have to turn one of those wholes into a fraction. And I'm going to choose a fraction with fourths because our denominator is 4 for this problem. We learned earlier that 4/4, any number on top, if it's the same on top as on the bottom, that is one whole. Okay? Because all of it's shaded in. The whole thing is shaded in. You have all 4 pieces. So 2 is the same thing as 1 plus 4/4, but we can't forget our fraction. We have to add that back in there. So now our new number looks like 1 and, oops, let me rewrite that. 4. 1 and 4 plus 1 is 5. 1 and 5/4. So that's what our new number looks like. This gave us a bigger numerator to be able to subtract 3 from. All right, so this one didn't change at all. Minus 1 and 3/4. We can subtract that. 1 minus 1 is, I'm going to use a different color for that. 1 minus 1 is 0. And different color for the next one. 5/4 minus 3/4. Fourth stays the same. 5 minus 3 is 2. And then we rewrite it. That's just 2/4, but I can divide it by 2 to simplify, and that's half. Okay. This one is a little bit tricky, so let's do another one. Trying to think of a problem. Let's do 4, 5. No. Oops. 5 and 2/5 minus 1 and 6. Nope, 6 doesn't work. Let's do 1 and 4/5, just so that it's still a real mixed number. Okay, so we have the same problem where the numerator is too small to subtract from. We haven't learned about negative numbers yet, so we can't do that. We have to regroup. So we're going to pull out a whole from the 5, and that whole is actually going to be written as a fraction, so 5/5. And I'm keeping it fifths because that's our denominator, just to keep it easy. All right. So when we rewrite it, we also have to include our existing fraction in our mixed number. And so when we rewrite it, it's going to be 4 wholes, and the fifths stay the same. 5 plus 2 is 7. So 4 and 7/5. Now you subtract. Remember, your 1 and 4/5 needs no change. Stays the same. 4 minus 1. Let me use different colors so you can see. 4 minus 1 is 3. 7/5 minus 4/5. Fifth stays the same. 7 minus 4 is 3. And the greatest common factor for 3 and 5 is 1, so there's no change. This is my final answer, 3 and 3/5.